So scientists at Tufts University have created the world's smallest motor. It is insanely small.
Essentially, it's like the size of a human hair.
Well, it's 1/60,000th of a human hair, right? I mean, it says, yeah, the article says about 60,000 of them equal the width of a human hair. So it's just incredibly mind-bogglingly small, and
it's like the sharpest. What it is, it's a needle. It's the sharpest needle in the world, and it's so precise that it can fuel a single molecule while leaving the surrounding molecules dormant.
Right, leaving them off, so you can power on one, and right next to it, a couple nanometers off. It's amazing. It's absolutely incredible. I mean, your mind, can really go a long way toward thinking about imagining what they could use this for. They could use it for all kinds of things. They could use it for, devices that go into people's bodies for surgeries, right? They could use it for, computers.
Intravenous things, getting into places in the human body that they've never been
off limits before.
Yeah.
So amazing discovery. The article's linked down below if you guys want to check it out. It's pretty cool stuff.
Yeah, it's just amazing. Nanotechnology is we're kind of just on the cusp of really getting this going. This research was conducted in negative 450 degree temperatures. So that helped to keep those remaining molecules, the sulfide molecules. It was used on butyl methyl sulfide, which says here it gives brandy its distinctive smell, and it was placed on a copper surface, and then that way they could see which way, how the molecules were moving and which molecules were moving. But they, kind of attribute the surrounding molecules not
being all connected.
Yeah, or not taking having the motor have an effect on them, remaining dormant. I mean, that's kind of they attribute a lot of that to the temperature and to the copper plates and the types of molecules that they are. So it's like the first step. It's a very small step, because of course, our bodies aren't at negative 450 degrees.
Yeah, I mean, it's definitely initial, just initial demonstration. But there have been other molecular motors in the past that are almost as small, but the difference between this one and those is that this one can be powered by electricity, which allows them to control the individual motors, as opposed to if it's controlled by light or heat or whatever, it's harder to have pinpoint accuracy.
Right. So this needle would shoot electrons down into the molecules, and that's what the needle's so sharp, and the fact that it's electrons, it's a very fine charge. So it's just amazing. We're seeing the first steps, and we're seeing this slowly develop, but we're seeing it develop.